Give me 1 minute, guys. All right. Good afternoon. Sorry for the late start. Because this is supposed to be a class for all of grade 11, and this Zoom account only hosts 100 person. I was trying to ensure that we have YouTube live feed, so that if it is a case where we actually get to 100 persons, they can watch via YouTube. That is why there was the delay. So I mean, we're far from 100 right now. So we are going to start. And I like to start with prayer. So let us pray. Heavenly Father, we thank you for a beautiful day that you have made. Thank you, God, that we are alive, that you have provided for all of us who are already here, internet and device, that we can be here. Lord, I pray for all these students who are taking the time out to put in the extra work that is required for them to do well on their exams. I pray that they will indeed do well on their exams, that whatever material we cover, able to retain it. I ask, dear God, that you'll give them the ability to focus when it is time for them to study and to do what it is required of them to be successful. I thank you, Lord, for these mercies. In Jesus' name, amen. All right, so I have turned off. You are unable to unmute at the moment. That is just for a control purpose. But if you have a question or you want to say something, then simply raise your hand and I will allow you to unmute. This is annoying. All right, so the topic that we're starting off with, and we group the questions by topic based on how they are in the multiple choice, on the multiple choice paper. So for the multiple choice exam, there are 60 questions, right? And it covers all the topics that is on the syllabus, 60 questions. So we have divided it into about 8 topics, right? Based on how the paper is set up. And so I'm starting with geometry and trigonometry. Now, some of these things you would have done from grade 7, 8, 9. In fact, all of this you would have covered between grade 7, 8, and 9, most of it anyways. So I'm going to do a little review and then we actually look at the multiple choice questions by year. I have past papers from 2011 to about 2018 or 2019. The class should be 1 hour. So we're gonna finish at about 4:40, right? All right, so the first thing that we are looking at is Pythagoras theorem. Right, 5:40. I don't know what time I said, but 5:40. The first thing that we're looking at is Pythagoras theorem. Anybody knows what that is, what that is about? You can just raise your hand. It's a teaching and learning experience, yeah? Anybody remember Pythagoras theorem? Anybody been going to an extra class and they reviewed Pythagoras theorem with you? Because you actually did this in grade 9. All right, Johnny, go ahead. Unmute.
Miss, repeat the question, Miss. Whenever
I'm asking, do you remember what Pythagoras theorem is, or what it's about, what it's used for?
Miss, to find the hypotenuse or something.
All right, so you have an idea. You said to find the hypotenuse. The only thing is that it's not just the hypotenuse, right? All right. Tevon, change your mind.
Miss, is it to find the size of a missing side of a triangle?
All right, so it is used to find the missing length of a triangle. But is it just any triangle or a specific type of triangle? Ashanti.
Miss, I know that the equation that you would use is a squared plus b squared is equal to c squared.
Yes, that is correct. All right, somebody's in the chat. All right, so Tyree said it in the chat. It is used to find the missing length or missing side of a triangle, but not just any triangle, a right-angled triangle. And then Ashanti, I believe, gave us what the actual formula is. A squared plus b squared equals c squared. Looking at the triangle that is on the screen, what does the c represent on the triangle or in the formula? Which side of the triangle does the c represent? Tevon, I didn't see a Kayla.
Miss, the hypotenuse.
The hypotenuse. So that is very important to remember. In the formula, the C represents the hypotenuse, and then A and B is the short side. It doesn't matter what the order, it just A and B represents the two short sides, and the B could be here and the A could be there once the C is in the position of the hypotenuse. All right, so that is very important to remember. All right, so that is the formula. A squared plus B squared equals C squared. And then I just put in some questions. These are not from the CSEC paper yet. I just put in some questions for us to apply and just refresh our brains on how to use the formula. So we're given this question, or these two questions. Find the value of x using the Pythagorean theorem. All right, so the question is, which side is missing? Is it a short side or is it the hypotenuse? All right, somebody said it in the chat. Yeah, I need help. Oh Lord. Right, so it is said in the chat the hypotenuse is missing. Approaching the question, the first thing that you want to do is to write the formula. So a squared, I need to join it my tablet so I can write faster. A squared plus b squared equals c squared. And then we substitute what we have. So we know that the hypotenuse is missing. So we know that would be representing c. So a and b would be the 4 and the 3. So we would square 4 plus the square of 3, and that would be equal to x squared. We don't know what c is. That's what we want to find out. 4 squared, 16. 3 squared, 9. And that's equal to x squared. So 16 plus 9, that's 25. And 25 is equal to x squared. We don't want x squared, we want x. What do we do to find x? Ashanti, you can speak, unmute.
Means you're going to square root it.
Right, so we find the square root of both sides. So square root would cancel square, and so that means x is 5. What bad writing. All right. So who can write on the screen? You have that option. And find the missing value x for triangle 2. Any volunteer to write on the screen? All right, Yvonne. So you have to identify whether a short side or the hypotenuse is missing, right? So you know how to properly substitute. Right? So you know how to properly substitute. Yes, A can be 4. Are you asking a question? Go ahead, Tevon. So do you have C? All right, so you can go ahead. All right, so Tevon is rearranging the formula. Seeing that we want B, he has transposed the A squared, so it is now B squared equals C squared minus A squared. Julian? What kind of subtraction you do? No, is the subtraction wrong? Because you get 9. You get 8 instead of 9. All right, thank you, Tevon. Beautiful. So that is the correct answer. So we have the hypotenuse, which is 5. So the 5 had to be on this side of the equation originally in the substitution. And then we just substituted for the A and the B. 5 squared, 25. When the transpose, we bring over the A squared, it became negative A squared. So we ended up subtracting 16 from 25, which gave us 9. And of course, that is for x squared, and we don't want x squared, we want x. So we square root both sides, and we got 3. This formula is generally given on the paper. So this is one of the formula that is on the paper, the Pythagoras theorem. So it's not something that you have to say, study, but you just need to know what it is so that when you see it, you know that, oh, hey, this is it, and know when to use it and how to use it. Any questions before we move on? All right. So I'll work with those who respond. And Julene says she understands. So I'll work with her response. All right, so clear the screen. All right, so the next thing that we need to review are the trigonometric ratios. The trigonometric ratios. Kind of gave away the answer, or one of them. What are the trigonometric ratios that you would have learned? Anybody remember them? One is on the screen. You learned 3 trigonometric ratios. It would be nice if you sent it in the chat to everyone and not directly to me. I mean, it's nothing if you get it wrong. Yes, Stefan. I changed the settings so you can unmute when you need to speak. Once it doesn't get out of control, you'll be able to do that.
All right, Miss Sin, tan and cos.
Right. And that was said also in the chat by Tyrese. So it's sine, cosine, and tangent. That's the full name for each of them. Of course, we've shortened it to sin, cos, and tan. Right? And again, these are used in right-angled triangles. So Pythagoras' theorem is used to find missing lengths in right-angled triangles, but the trigonometric ratios take it to another level. They're used not only to find missing lengths, but missing angles. So the first ratio is sine ratio, and the sine theta is opposite over hypotenuse, and this refers to the right-angled triangle. So you have to be able to identify what angle is opposite, what angle, well, by now everybody should know the hypotenuse. So we have the triangle here. So if you are given an angle, all right, so no, Julian, sine is not used to find adjacent. cosine or tangent would do that. Sine is opposite over hypotenuse. So if you're given an angle theta, you know, we use the word theta, which is this symbol to find to represent a missing angle or an unknown angle. So if you're given this angle, then the side that is opposite to it must be on the other side of the triangle. So that's the side right here. And of course, your hypotenuse is always the slant side, right? So for this particular triangle, this would be opposite. But if I drew a triangle this direction, right angle triangle, and then I had the angle right here, A, I'm putting A over there, B, C. Which one of these sides, A, B, or C, is opposite to the angle that you are given?
Miss C.
C.
All right, so I heard the wrong answer and I heard the right answer. So it would be C. C is on the other side of the angle. So opposite is not set as how the hypotenuse is set. Opposite is in relation to the angle that you are given, right? So the hypotenuse is always the slant side, but the opposite side is in relation to the angle that you're given. So let me mark up the screen some more. What if the angle, the triangle is drawn like this? And we have the angle right here. Let me label it the same way, A, B, C. Which one of the sides would be opposite to the angle?
B.
B.
Wonderful.
B.
Great. So it would be B that is opposite to the angle. All right, so that's important to note because you can know the formula, but then if you can't identify what is opposite versus what is adjacent, then you'd still end up getting the question wrong. So that is important to know. So sin is opposite over hypotenuse, and then we go to cos, which is cosine. And cosine now is used when you have the side adjacent to the angle and the hypotenuse. So for the adjacent side, I mean, if you are able to identify opposite and you're able to identify hypotenuse, then automatically you know the adjacent, right? It would be what is left because the triangle only has 3 sides. And yeah, the adjacent side is always beside the angle. Of course, I could say that the hypotenuse is beside the angle too, but if you know what the hypotenuse is, then you know what the adjacent is. So the angle is generally between the adjacent side and the hypotenuse. Here's the angle, and it's between the adjacent side and the hypotenuse. Once you identify the slant side to be the hypotenuse, then the next one is the adjacent side. Any question? All right, so let's look. I mean, that's a giveaway. It doesn't make any sense. All right, moving on. All right, tan. Anybody know the ratio for tan? What over what?
Opposite over
Adjacent.
Oh, wonderful. So tan is opposite over adjacent. So it's almost like you take a piece of sine and you take a piece of cosine and you get tan. And of course, I wouldn't really need to explain that because I would have explained opposite and adjacent already for the last 2 ratios, right? So it's just to remember. And as acronym that we use to remember it is SOHCAHTOA. SOHCAHTOA. So S sine opposite over hypotenuse, that's so. Ka cosine adjacent over hypotenuse, and tower tan opposite over adjacent. It's easy to remember, right? Because it's weird. SOHCAHTOA. All right. And this is what I already explained. Opposite is opposite to the angle that you are given. Adjacent is between the right angle and the angle that you are given. Yes, aren't weird things easy to remember because they're weird, like you're saying that is so odd. I can't forget that. Maybe it's me alone. I don't know. Sorry about that. All right, so clear. We're almost at the questions. If you guys are not busy, then I might extend the time a little bit so we get in more of the multiple choice questions. But I'd rather just stop and review before going into the question and shuffle. All right, some little geometry things to remember. The sum of interior angles in a triangle is, or angles in a triangle add up to?
180.
180.
Last time I asked that question, somebody said 360 degrees. Lord help us. But anyways, so the sum of the interior angles in a triangle is 180 degrees. How about the rectangle or any quadrilateral?
The one that's on foreign miss.
Rectangle?
90.
No, the sum of all the angles in the rectangle.
360.
360.
Oh yeah.
Sound foreign. All right. All right, so this one says alternate angles are equal. And just in case you don't remember what alternate angles are, if you have a pair of parallel lines cut by a transversal, that's a straight line right there. All these lines are straight. Then if you look at it carefully, you will see a Z being formed. I call alternate angles Z angles. So see the Z here. So angles in the corner of the Z, as I like to say, they are equal. So this is for the rule alternate angles are equal. So if this angle is 50, that means that this one down here is also 50. That's all that is saying. Do I still need to give an example, Jeline? Why is my chat so big? Chat, minimize. All right, great. The next one. Vertically opposite angles are equal. So that would look something like this. If you have an X, this where the lines meet, that would be the vertex. So angles on opposite side of the vertex, they are the same. So whatever this angle is, this angle would be the same. So if this is 20, that is 20. Angles on a straight line add up to
180.
All right, so that's vertically opposite angles, and I just randomly brought in angles on a straight line. And the next point I made was that to find the size, let me clear the screen. To find the size of an exterior angle for a regular polygon, divide 360 by the number of sides. So let me attempt to draw a polygon with 7 sides, 6 sides. It's not a straight line. So let's say I have this 6-sided polygon. All these lines have the same length here. It doesn't matter what it looks like. So this is a 6-sided polygon. 1, 2, yeah, that is a 6-sided polygon. By exterior angle, I mean that if I extend each side, so if I extend that side right there, or I extend that side right there, what is the angle? All right, that's what we mean by exterior angle. So if you want to find out what is the side and all the exterior angle in whichever polygon, once it's a regular polygon, all of them are the same size. So we divide 360 by the number of sides it has, and that will give us the size of one exterior angle. So seeing that this is a 6-sided polygon, we would divide 360 by 6. And that would mean that one exterior angle for a 6-sided polygon would be 60. 6 into 6, 1. 6 into 36, 6. 6 into 0, 0. So that's 60. So the answer for that is 60. So hopefully you remember all of that. Now we're actually going to go into the multiple choice questions from CSEC. Let me check the chats. No, a polygon doesn't always have 6 sides. Polygons have all number of sides, remember? So you start with a 3-sided polygon.
This one can go to 542, right? 540 degrees.
Yeah, man, yeah. Because, so I think 540 is for a 5-sided polygon. Remember,
Pentagon.
triangle 3-side, quadrilateral 4-side, then pentagon 5-side, heptagon 6-side, no, hexagon 6-side, heptagon, septagon, octagon 8-side, nonagon 9-side, stenagon, decagon.
Decagon and dodecagon.
Right, dodecagon, undecagon, right? So it goes on and on. A polygon can have any number of sides, right? Yeah, it's not just shape, but there must be straight lines. So a circle is not a polygon because it doesn't have any sides really. It's just one continuous curve going around, right? All right, so wonderful. So moving on, clear all drawings. All right, so let's get into the meat of the matter, which is the matter of the meat. All right, so this question is starting with 2012. So I didn't put 2010 and 2011 questions. So we're starting at 2012 and water break. All right, so bearings you have not done as yet. I think for some persons, it's possible that some persons would have done it, but most persons haven't done bearings because that should have been done in grade 10. Some persons' teacher might try to finish trigonometry. That is what it is, right? But you still have to know it because this is a question that is on the paper almost every year. So you learn it now. So it says a boat was traveling on a bearing of 270 degrees. In what direction was it traveling? All right, so what you need to know about bearing is that once they mention bearing, you draw a north line. What is a north line? You see a line that is going in the north direction. So you draw a north line. That's your north line. And then you would measure from there the angle that you are given. So seeing that it's 270 degrees, it can easily be done. 270 degrees is formed from 390 degrees. So you know what a 90-degree angle looks like. I mean, the easiest way to do this is actually to just draw the points. So let me do that. Annotate. So now, so this is straight, right? It doesn't matter how lean it looks, it's straight. And you know that's north up here, south, west, east. So we know that from, this is 90. 90 plus 90, that's 180. And 180 plus 90 more, that gives us 270. So where does it bring us to? North, south, west, or east? Where did we,
Which way west again?
so we ended up at west. So it's on a bearing of 270 degrees. So we'll draw out the cardinal point, find 270 degrees. This is 90 right here. This covers 180, and this is 270. So it brings us right at west. So our answer is B, west. And you're going to see this question again. All right, so bear that in mind. So that is west. All right, number 60. The height of the building is approximately, all right, so here's the actual first part of the question. A boy stands 12 meters from the foot of the building. So here, this is the building, this is the foot. He's standing 12 meters away from it. And all right, so I'm gonna ask the teachers who are online to monitor the chat. Sorry, to monitor, you know, here and there and everywhere, please, if you can. So a boy stands 12 meters from the foot of the building and observes the angle of elevation of the top of the building. So this is something that you did in grade 9. Of course, you don't remember, but it uses trigonometric ratio. Angle of elevation is the angle formed when you look up at something. All right? So it's the angle formed between you looking straight ahead and turning your head upwards to look at the thing. So it's that angle right in between there. And here's the diagram. So this is the boy. I mean, they have his eyes in the wrong direction. But here is him looking straight across, and this is when he looks up to the top of the building. And they said that the angle of elevation for that is 40 degrees. The question is, what is the height of the building approximately?
D.
Somebody said D. Is that what you said, D?
Dog. D.
I'm here dog, I'm here B. Well, at least that's why you gave the word, right? So B. All right, somebody said D, somebody said B.
D miss 1.6 plus 12 tan 40 degrees.
All right, so I'm getting. All right, so let us see. So seeing that we want the whole height of the building, right? We have to include the height of the boy. That is why they gave you. And then now using our trig ratio, the appropriate one, we would be able to find the missing length right here. We have this length right here because if this is a rectangle, this is 12, that means right here is also 12. So we are given, in relation to the angle, what is this side? The 12. Adjacent, opposite, hypotenuse, what is the 12?
Opposite.
Adjacent.
Tevon, opposite.
Never me say it, miss.
All right, sir. So it's the adjacent. Remember, the adjacent is right beside the angle. So the 12 is adjacent. And then the side that we want is on the opposite side. So you ask yourself the question, which one of the ratios use opposite and adjacent? Which one? Sine, cosine, or tan? Sokator, which one?
Tan.
Tan. Thank you, Ashanti. So tan is opposite over adjacent. So that means tan would be what is used to find the missing angle. So the answer would be the answer with tan plus the 1.6. So that would be D, 1.6 plus 12 tan 40. Any question? And you're going to see this question again. All right, no questions, so we move on. And I will have the answer. All right, question. If the sum of the interior angles of a polygon is 4 right angles, the polygon is a
Quadrilateral.
Quadrilateral.
Anybody have a different answer? No, I didn't.
Oh, miss.
So it is a quadrilateral. 4 right angles. I don't need to draw it, right? All right, number 56. The item 56 refers to the isosceles triangle below. First of all, what is the isosceles triangle?
Miss
A
two,
triangle
Miss
that
have two
has
equal sides.
2 equal sides.
Wonderful. So it's a triangle with 2 equal sides. So in the triangle, what is the value of x? So I'm giving you a chance to work it out first.
100.
80. Wait, sorry.
Miss
100.
100.
100.
100.
100.
You guys are thinking fast. So it's 100 because this side would also be 40. 40 plus 40, 80. 80 from 180 is 100. Wonderful. Anybody didn't get that? So just to be clear, angles in a triangle add up to 180. So we would have done 180 minus 2 times 40. So that's how we got the 100. All right, next question. This one, I don't know how to explain it to you. I just know the answer is 60 degrees. And you would have done construction. It was in grade 9? In grade 9.
Miss.
Mm-hmm.
This one is asking for the angle.
Mm-hmm.
Well, okay.
So if you know how to construct different angles, then by you would know that the angle is actually 60 degrees. Another thing that you can do.
So you get 60.
Yeah, you could use a. Excuse me, sorry.
Go ahead, Mrs. Reese.
Yes. Also, they could have used their protractor to measure it.
I'm not sure protractors are allowed in the multiple choice exam.
Oh, multiple choice now. Yeah, but as you were saying, just as by looking at the diagram, you would know that that is actually a 60 degree, and we have done that in grade
9.
Yes, we have done that in grade 9.
All right. So another way to look at it, I draw a straight line up, and you know that this whole thing would be 90 degrees, right? And this
Yes, miss.
is obviously more than halfway in the 90. So that means it's past the 30, past the 45, and hopefully you know that it never reached 75. So it is 60 degrees. All right, but they don't normally change it. It's normally always this diagram. So you just need to remember that it's 60 degrees for this diagram. All right, the next question. In a triangle ABC, angle A is x degrees and angle B is 2x degrees. What is the size of angle C?
D, miss.
C.
D.
All right, so I hear C. What else?
D.
D. Dog.
D. All right, anybody for A? Anybody for B?
Miss C.
All right, we're just gonna get trouble. All
So
right,
that's how we
C.
D.
Jolene Bloomfield says C in the chat.
Thank you, sir. All right, so some persons are saying C, some persons are saying D. All right, angles in a triangle add up to 180 degrees. And triangles have 3 sides, and they give you 2 sides of the triangle. How do you find the third side if you are given 2 sides?
Miss
Miss, you add up
miss
the
add the
two
two
sides
sides
and then
and take
subtract
away
it from
from
180.
Wonderful. So you add the 2 sides that you are given and you subtract it from 180. So it would be 2x plus x, that's 3x, and we subtract that from 180. So our answer would be D, 180 minus 3x. All right, Julian. So answer is D, right? And I have it on the next slide. Is that clear? We can move on to the next. Take that as a yes. All right. So those were all the questions on the geometry and trigonometry on the 2012 paper. So now we are at 2013. And the first question that is there is a question we've already done. You see that? Repeat already. From one year to the next. So it says if the sum of the interior angles of a polygon is 4 right angle, what is the polygon?
Quadrilateral.
Quadrilateral. Yes, D is the answer. All right, number 53 refers to this diagram right here. It says AB, so that's this line, and CD are parallel. Which of the following best describes the relation between X and Y? And Bradley has
X is
put,
equal
A,
to
miss.
Y. A.
anybody has any different answer? I just want to find out. All right, nobody has a different answer. The answer is indeed X equal Y. So this is the alternate angle thing that I reviewed in the beginning. So if you look, you see the Z, and we said that alternate angles are equal, right? So X equal Y. Yes, Bradley A. You got it right the first time. All right, number 54, another easy polygon question.
120.
And Asan, you're sharp like that. All right, Julian sending answer, Bradley. Anybody have a different answer? I just have to check, you know. So no. So yes, you guys are correct. The answer is 120. So we know that they gave us 2 sides. So 30 plus 30, 60. and we subtract that from 180 and we get 120. All right, giving 10 seconds to let it soak in. All right. It's soaking. Right. Item 57 refers to the triangle ABC below. In the triangle not drawn to scale, angle BAC equals 30 degrees and AB equals 40 meter. The length BC in meters is, so we want this side over here. This side is what in relation to the angle?
The opposite side.
The opposite side.
Wonderful. So it's the opposite side. So we want the opposite side. We have the hypotenuse. Which one of the trig ratios use opposite and hypotenuse? Sine or tan?
Sine.
Sin.
All right.
A.
No, miss, we said D.
You have to look carefully now because yes, it is sine, but notice they give you two things with sine in it, one with 30 and one with 60. Which one is it?
A, me say.
A.
It's 30 that is in the triangle, so that it's 40 sine 30. All right, so the answer for that one is A, 40 sine 30. Number 59. A plane is flying in a direction of 0.45 degrees. That means it's actually flying on a bearing of 45 degrees and changes course in a clockwise direction to 135 degrees. The angle through which the plane turns is, Tyree is too bright. How did you get your answer, Tyrese?
Miss 90 because me see the 45 there.
All right, so I'm going to try to explain it. Maybe another teacher can explain it better than I do. All right, so again, for bearings, you start at the north line. So they said the plane was on a bearing of 45 degrees. 45 is half of 90. So that means the plane was right there. And then it moved to 135.
Miss.
To 130. Yes, yes.
The plane moved from 45 to 135, and 90 degrees that it had on. Miss, you're muted.
My background was noisy and I muted myself. All right. Yes, I was saying that's one way to get to the answer, simply subtracting 145 from 135. I mean, they can just use that. I don't have to use the whole diagram to explain. Yes, I'm not going to use the diagram to explain because it might cause more confusion. So we'll just work with us subtracting 45 from 135. I don't know if Mr. Sharp want to add to that or Mrs. Reese.
I think that's the easiest explanation, seeing that they haven't done buying bearings as yet. But you could probably do the small sketch of the diagram and kind of show them how the 90-degree form between them. I don't know. But that's the best explanation, I guess.
It is reliable, Julian. Hopefully I drew a diagram on that man like and I'm gonna delete my diagram. All right, so north line 45 degrees, and it said it changed course in a clockwise direction to 135 degrees.
Include the 90 degrees, so they can also see that there's 245 that would give you that. You get what I'm saying? Include the 90 degree as well, and then you draw the other 45 degree. Probably that can give them a better explanation.
Let me erase this, I don't want that line. So just in case you're wondering, this whole thing would be 90. My line supposedly is halfway between this 90.
Not drawn to scale.
Not drawn to scale, right? Not drawn to scale. So this is the whole 90, and then 90 plus 45 more gives us the 130.
135.
135. So again, this line would actually take us to 135. So 45 plus 45, 90, plus 45, 135. And if you look carefully, diagram not drawn to scale, you would actually see that a right angle is
right. The degrees on the lines, so they can see it.
Oh, yeah.
Like
so right in here is the 45. Of course, this is the 90 mark. And this is 135. So moving from this 45-degree line to the 135, we see that we actually end up with a right angle. Use a different color. So from the 45 to the 135, we end up with the right angle. Are you guys seeing that? Okay.
Jolene says she got it. She get it.
Okay. All right, so next. Ding, 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 ding. So those are all the questions from 2013. Now we're at 2014. And as I said, you will always see questions being repeated because that's just what they do best. So number 52, what is the measure of the angle?
60.
6
Is they made the two same one will come back again.
Yup, 60 degrees.
They can skip that one day.
And number 53, the answer is
C.
What's the answer, Tevan?
For 53, miss?
Yes, 53.
C, 100.
Oh, I thought I heard B. Just checking.
No.
Okay. So it is C, 100. 40 plus 40, 80 from 180, that's 100. Just to be clear. Just to hoping that it cement in and stay in. All right, a different kind of a question. Which of the following statements best describe the properties of an equilateral triangle? Equilateral triangle.
A.
A.
Here you are just waiting to see if anybody has anything else. And I hope they're not intimidated by the persons who answer first. All right. So let us see. A says 1 and 2
And
only.
it says all A in the chat.
Okay. So A says 1 and 2 only. Let's see what 1 and 2 says. All sides are equal. All angles are equal. All right. So yes, the answer is A. It's an equilateral triangle after all. All right. Number 55. In the triangle ABC, not drawn to scale, AB is 17 centimeter, AC is 15 centimeter. What is BC? And they tell you that this is 90 degrees, so it's a right angle triangle. First of all, which formula are you going to use to find X?
Miss the PT something.
Pythagoras theorem.
Yes, miss that.
All right. Very good, Garisha. So we would use the Pythagoras theorem to find it. Anybody volunteer? All right. So once it does not involve an angle, meaning it's a right angle triangle, they don't give you any other angle in it, then you use Pythagoras theorem. If it involves the right angle and another angle, then you can use sine, cosine, or tan. All right. So once you have two sides of the triangle and you want the other side, it is going to be Pythagoras theorem. All right, so I'm giving you a few seconds to work it out yourself before I do anything. Garisha already told us we're using Pythagoras theorem.
Miss 8.
All right, I see 8 in the chat and I hear 8 out loud from Garisha, I think. Anybody else finish? All right, so waiting 15 more seconds to see if anybody else will give us another answer or their answer. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
8.
All right, so everybody I get 8. So let's work it out.
Correction, Miss 6.
6, but 6 is not in the option.
Sorry, 8.
I go ahead and adjust. Yeah, I worked it out already. All right, so you guys got it right. It is 8. So the Pythagoras theorem is a squared plus b squared equals c squared. We recognize that they gave us c, so the 17 is out here. And then we have the 15 squared and x squared over here. And then we transpose the 225, so we subtract 289 minus 225, and we get 64. And of course, we find the square root of 64, and we got 8. Any question? I realize it's the same about 5 or 6 persons answering. Remember, don't be afraid to ask a question if you don't understand. That's why we're here. All right?
Yes, I don't understand.
All right, Antoine.
Antoine.
Tell me exactly which part you don't understand, Antoine.
Kind of highlight.
So the first question is, were you here when we were reviewing Pythagoras theorem?
Yeah. No.
Okay. All right, so that's it. All right, so Pythagoras theorem says a squared plus b squared equals c squared. What does that mean? It means that if you have a right angle triangle, A and B is going to be the two short sides, and C is going to be the hypotenuse, which is the longest side on the triangle. So this is A, that is B, or this is A, that is B, but this longest side must be C. And as the formula says, A squared plus B squared equals C squared. So you substitute the sides that you have in the formula and you solve. And somebody said it's taking a while for this part to soak in. Look like we should attend Pythagoras question. So even though I have it written out there, I'm gonna just go through it just the same. Why change a to x? It didn't have to, but because they labeled the side x, we just put x to say that this is the side that is missing. Right. So the formula, and I'm just going through it for the persons that said they don't understand. A squared plus b squared equals c squared. Remember, we say C is always the hypotenuse, the longest side on the triangle. Most times it's a slant side, but in this case, it's not the slant side, right? So they have given us the longest side, C. So we put the 17 over here. And for the two short sides, it doesn't matter what order you write them in. So you can write the 15 first or the x first, it doesn't matter really. So even though over here I have x squared plus 15 squared, I'm gonna switch it up and put the 15 first. 15 is one of the short sides. Can still leave b as it is, but I'm going to call it x because that's the side that we don't know. X squared. Work it out, 15 squared, that's 15 times 15, not 15 times 2, no. 225. And 17 squared, 17 times 17, that's 289. We want x, so we have to transpose. So we're moving the 225 to the other side of the equal sign. We must do the opposite. So it was positive over here, it will become negative on the other side. So then we'll have x squared equals 289 minus 225. And the writings become harder. So we do our subtraction, and we have x squared equals 64. But we don't want x squared, we want x. So we have to get rid of the square. So we do the opposite, which is to square root both sides. So square root will cancel square over here, so we're left with x. And the square root of 64, what was multiplied by itself to give us 64?
8.
That is 8. So I hope it's at least one step clearer or 2 steps clearer. Can I move on?
Yes.
Yes.
Yes, miss.
Okay. All right, so clear all drawing. Next. All right. Item 57 refers to the diagram below. Here's the diagram that is below. In the right angle triangle above, which trigonometric ratio is equal to 4/8?
Miss cos X.
All right, so Garisha says cos X. So Garisha says C. Anybody else? Julene also says C. Anybody else?
C.
Tevon says C. All right, so it's C. Okay, let us see. All right, so C is cos X. So let's look at what we have. X, 4 is opposite to X, and 8 is the hypotenuse. So what we have in relation to X is opposite and hypotenuse. Which one of the ratio use opposite and hypotenuse?
Sin.
Miss.
Sin.
So the answer is A.
So the answer is A. So it's sine X that actually gives us 4/8. So again, the 4 is opposite to X, 8 is our hypotenuse, and sine use opposites and hypotenuse, so it has to be sine X. It's a sin.
Miss, I don't understand.
Garisha, you missed the revision as well? I just want to know, you missed the revision when we were going through the trigonometric ratios?
Yes, Miss.
All right, so for the trigonometric ratios, it's SOHCAHTOA.
Oh, yes, Miss, I was here.
You are here.
Yes, Miss.
So, ha.
And TOA.
So how do you know which one to use when it involves the two things that ratio use? That's when you use it. So for this one, we have the opposite and we have the hypotenuse. And sin is the one that use opposite and hypotenuse. So that's how we know it is sin. We can verify with the other ones. We can check the other ones to actually X them out. So let's look at tan Y.
Yes, Miss, I get it.
Okay, but we're actually going to do it. So in tan Y, tan is adjacent over hypotenuse, not hypotenuse, opposite over adjacent, right? That's tan. Opposite of tan is down here and nothing is there. So right away, it's out because it doesn't involve the 4 or the 8. Cos X, cos is adjacent over hypotenuse, and adjacent again is right here and nothing is there. So that means it's not the 4. So that X out the cos. If it was tan X, it would be opposite over adjacent, right? So the 4 would be right, but the adjacent is down here and 8 is not down here. So that means it would not be tan. So that's how we eliminate. All right, number 60. All right, we're gonna try to hope at 6 o'clock. I think we have to if we need to, because as we're at about 2016 and this goes up to, we're at 2015 and this goes up to 2018. But I'll try and wrap up by 6. Don't want to weary you. All right, number 16. In a triangle ABC, so we got this question already. What is the answer?
D.
D, wonderful. So angles in the triangle add up to 180. So we add the 2x and the x, that's 3x, and we subtract it from 180 to get the missing angle. All right, so next question. All right, so
How much time is I gonna repeat?
that's what I'm saying. So that's why we're actually going through this with you guys. Hopefully you see the same question 10 times. By the time you go in at the exam and you see it again, you know the answer just like that. So you can get at least 55 out of 60 for the multiple choice question on your way to passing with your nice clean SBA grade, right? All right. So the answer for the first question is
Quadrilateral.
wonderful. And the question for this one is not there. But we know that it was x equal y, right? And this question again, number 54 is repeat. What's the answer?
30. 60. 60.
100.
120.
120.
Please to read the questions carefully. Thank you very much. So it's 120. Don't just add the 30 and the 30 and stop there. Remember to subtract it from the 180.
Yes, miss.
So it's 120. I think this is this a repeat question. I don't remember. I think so. In the triangle not drawn to scale, angle BAC is 30 degrees. AB is 40 meters. What is the length of BC? So in relation to the angle BC is what? Opposite, adjacent, what is it?
Opposite.
Opposite.
And we have the 40 is what over here?
Hypotenuse.
Right, so which one of the ratios use opposite and hypotenuse?
Sin.
Right, and they have 30 degrees in the triangle, so which one of them is the answer?
A.
A, wonderful. All right, so this is null and void. The diagram is not there for it. All right, fairly newish question. Let me clear the drawing. All right, easy question. Item 59 refers to the diagram below, which shows a ladder. Here's the ladder, 5 meters long. So you can put that in. Leaning against a vertical wall. They labeled the wall for you. And the foot of the ladder is on horizontal ground, 3 meters away from the wall. How far up the wall does the ladder reach? So in other words, they want this length right here. What are you going to use to find the length? Just too bright. What are we going to use to find the length?
A square something
Mr.
like that.
Pythagoras.
Pythagoras theorem.
Pythagoras theorem. The square something. All right, so Pythagoras theorem, A square, and maybe you've heard mention of a 3, 4, 5 triangle. Maybe. So we have the hypotenuse, so that's 5 out here. And we have one of the short sides, so I can put 3 right here.
I can go anywhere. It can be either A or B.
Yeah, man, it can go anywhere. Once you have the C in the right place, A and B can, interchange. So again, Julian, you use the Pythagoras theorem when you have 2 sides of the triangle and you want to find the third side. For the trig ratios, you're only going to be given one side of the triangle and one.
Did you say right? Did you say right angle triangle? Because I hear like you only say triangle.
Right angle triangle. If me never say it, I'm going to say right angle triangle, right? For Pythagoras theorem and the trig ratios, it's always used with the right angled triangle. That's so key. right-angled triangles. All right?
Miss, the answer is 4.
Yes, the answer is 4. So I was saying once you have two sides of the triangle and you want the other side, it's Pythagoras theorem. Over time, you know, it will soak in. So of course, this would have been 25 minus 9, which is 16. The square root of 16 is 4. Anybody need me to finish writing that? Nah.
Yes, miss. Yes, miss.
All right. So this 3 squared would be 9. This is 9. Let me draw it. Plus b squared is 25. We want the b, so we transpose, we move the 9, so we can have b alone on that side. So it's positive over here, so of course it becomes negative on the other side. So that's going to be b squared equals 25 minus 9. 25 minus 9 is 16. So we have b squared equals 16.
And then find the square root.
And then you find the square root of 16, and that will give you b. So, and the square root of 16 is 4. All right, and number 60 is a repeat question. What's the answer?
I think this one was D.
All right, so I don't want you to remember the letters, I want you to remember the answer. Because what CSEC does sometimes, they switch up the answers, the order of the answer. So it will be the same question, but the answer, if it was in 2015 at D, it can be in 2016 at B. So study the answers instead of the question, instead of the letter A, B, C, or D, all right? But yes, it was tan, and we have to include the height of the boy. Them all change up them the diagram. So it was D, 1.6 plus 12 tan 40.
Miss, I don't understand that one. It look different.
All right, so this is the last one, right? I'm not going to go any further because it's 6:01. Yeah. All right, so this is now angle of elevation and depression. And I was explaining that angle of elevation is angle formed between you looking straight across and you holding your head up to look at something. So if you look at this line represents the boy looking directly across, and then this represents him lifting up his head to look to the top of the building. The angle formed in here is called the angle of elevation. And for this question, they said it was 40. The question says the surveyor sets up his instruments 12 meters from the foot of a building and records the angle of elevation at the top of the building, and that was 40. And they ask you for an estimated height of the building. Now they tell you that this guy is 1.6 meter. So that means this length of the building is 1.6, right? You want the full length of the building, so you need to find this missing length up here. So you're using trig ratio because it's a right angle triangle and you are given another angle and you want a missing side. So this set side over here is opposite to the 40 degree. We don't know this, but if this is 12, that means right here is also 12. This is adjacent. So we have adjacent down here and opposite here. And the
Mister,
rate,
if right there says 1.6, that means up there says 1.6, the guy look kind of half.
no, don't do that no. Them always telling that drawn to scales. I wonder they never put it.
Okay.
No, you cannot assume that. Not at all. And if you notice, they only have 1.6 one time. Let me erase my line so that you can see clearly. It does not look like half to me. It look like half to you, no?
Oh no, miss. No.
It's not half. But we know that down here, from here to here is 1.6 based on what they have right here. So we would want this missing length, and we have this length down here, which is 12. So remember, the adjacent is the side beside the angle. So that's 12. So we have adjacent, and we want opposite. And the ratio that uses opposite and adjacent is tan. Toa. Tan. So we know that our answer must involve tan. It cannot be A because it doesn't put the 1.6 in it, and we want the total height of the building. So it has to be D, 1.6 plus 12 tan 40. I hope it is a bit clearer for the person that...
Miss, I have a question. Why is it not C by chance?
What is cost, Julian?
I'm just asking. Just
No,
curious.
it's fine, but I'm asking you back a question to help you answer your question. What does cost use? Opposite, adjacent, hypotenuse? What does cost use, Julian?
Adjacent and hypotenuse.
Does your question, what they're asking for and what you have, does it involve hypotenuse any at all?
No, there's nothing at the hypotenuse.
Nothing there, and you actually don't want it. So that is why it could not be C, because it's cost, and we're not doing anything involving the hypotenuse. Right? So any other question? I'm not gonna stretch your brain any further. It's past 6 o'clock. All right, being that there's no question, no other question, thank you all for coming. I can tell you from the result of COVID last year, the persons who were consistently on our multiple choice classes like this, most of them passed their exam. All right, so try your best once you have the time and the internet and the device to log on. All right, so enjoy the rest of your evening.
Yes, miss. You too.
Bye-bye.
Same to you, Miss. Bye.
Miss, thanks for your time for teaching, miss.
You're welcome.
All right, guys, take care.
Miss?
Think next week will be me? I think so.
Yes.
So I'll be a teacher next week.
All right, sir. Bye.
All right.
Somebody asked when again. It should actually be Tuesday next week. I 10 people left, but yeah.